Here we have a problem on logarithm. Okay, let's go with the question. Log base A of BC equals to X, log base B of CA equals to Y, and log base C of AB equals to Z. Then what is the value of 1 over X positive 1, positive 1 over Y positive 1, positive 1 over Z positive 1. Okay, using these information, we have to find the value of this expression over here. Okay, now what I'm going to do is I'm going to find the value of the expressions we have in denominators over here. Okay, first let me find the stuff that is equal to x positive 1, which is in the denominator of the first fraction. Let me write x positive 1. Okay, in the given question, we have some stuff that is equal to x, that is log base A of BC. We can plug in this one for x over here. Then I'm getting log base A of BC positive 1. Here I cannot add this logarithm and the number 1 we have over here. If I want to add these two quantities, instead of number 1, I must have a logarithm. So what do we have to do for that? Let me do the stuff over here. Log base A of BC. This 1 can be written in terms of logarithm, that is log base A of A. Because in any logarithm, the argument and base are equal, then the value of such logarithm is 1. So instead of 1, we can write a logarithm with base and argument same. And also here we have a question. What do we have to write this particular logarithm for 1? Even we can write like a log base B of B or log base C of C. So why particularly we write logarithm with base and argument, both are A. So the reason is the first logarithm we have over here contains a base A. That's why I have written this number 1 in terms of logarithm with the same base of what we have over here. When I have the same base for both the logarithms over here, I'll be able to combine these two logarithms using the product rule of logarithm. What is the product rule of logarithm? Whenever we add two logarithms with the same base, what we can do is we can write logarithm once with the base of what we have, and we can multiply the arguments, that is BC and A. When I multiply BC and A, I am getting A, B, C. Okay, in the same way, I can get the stuff that is equal to Y positive 1. Let me do it, Y positive 1. And for Y, we have the stuff that is log base B of CA. Let me write over here, log base B of CA, positive 1. We have log base B of CA. And this 1 can be written in terms of logarithm. This time I am writing this one as a log base B of B, because for this logarithm we have the base B. So we have tried a logarithm for this one with the same base B. So here the base and argument are same. So the value of this logarithm is 1. Okay, here we add two logarithms with the same base. So we can use again the product rule. That is, we have tried logarithm once with whatever base we have for these two logarithms. And we have to multiply the arguments C, A and B. Then we get A, B, C. Now let me get the stuff that is equal to Z positive 1. Okay, let me write over here, Z positive 1 equals to, we know that log base C of AB equals to Z. So we can plug in this for Z over here. Then we get log base C of AB positive 1 equals to log AB to the base C positive. We can write this number 1 in terms of logarithm, that is log base C of C. Okay, here the value of this logarithm is 1 because the base and argument are equal. Now we are adding two logarithms with the same base C. So we can write logarithm once with the base of what we have, and we can multiply the arguments, that is A times B times C. Okay, now I got the stuff which are equal to the expressions x positive 1, y positive 1 and z positive 1 over here, here and here. Now what I can do is I can plug in these stuff for these expressions in this fraction, and we have to evaluate the value of this expression. Okay, now let me erase all the stuff and continue the problem. Okay, let's continue. Let's start evaluating the value of this expression. Let me write this expression as it is. It is 1 over x positive 1, positive 1 over y positive 1, positive 1 over z positive 1 equals to 1 over, already we got the stuff that is equal to x positive 1, that is log base A of ABC positive 1 over, and we got the stuff that is equal to y positive 1, that is log base B of ABC positive 1 over, and the stuff that is equal to z positive 1 is log base C of ABC. Okay, now what I can do is I can move this logarithm to the numerator. Whenever I move a logarithm from numerator to denominator or denominator to numerator, have to switch the argument and base of the logarithm. That is, the base over here will become the argument, and the argument over here will become the base when I move this logarithm to numerator. And also when I move this logarithm to numerator, it will be multiplied by 1. Then I'm getting 1 times of this logarithm is the same logarithm, and this argument ABC will become the base of of the logarithm, that is log base ABC of, so this base A will become the argument. The same thing will happen over here. So then I'm getting a log, so this argument ABC will become the base, and the base B will become the argument. And also we can move this logarithm to numerator, then we get log of, we have to switch the argument and base over here, then we get log base ABC of C. Okay, here we are adding three logarithms with the same base, ABC, ABC, ABC. Okay, here we can use a product rule of logarithm. That is, whenever we add two or more logarithms with the same base, what we can do is we can write logarithm once with the base of what we have for the logarithms, and we have to multiply the arguments A, B, and C. Then I'm getting A times B times C. Okay, now in this logarithm, the argument is A times B times C, and the base is also same, the A times B times C. In a logarithm, if the argument and base are same, then the value of such logarithm is just 1. Okay, now I got the value of this expression. The value of this expression is 1.